Hi, I'm David Bolton of Go Parallel, and today I'm going to be discussing some of the back-end technologies powering the Internet of Things and speculate as to what might be in the future, specifically what back-end technologies and programming languages are going to be used. What does Internet of Things actually mean? At its simplest, anything that contains electronics can be Internet connected. It can be controlled remotely and send data and status information across the Internet to wherever. The IoT is an interaction between the Internet, things and data. So it ranges from simple symbol board microprocessors like Arduino or Intel Edison up to powerful cloud servers communicating with thousands of devices. Much of the Internet of Things is machine-to-machine, known as M2M, a term originally from the telecoms world. The principle has been around for quite a while. In pre-web 1990, my house had a central heating system with a cheap overnight electricity tariff that was turned on and then off each night by radio signals. No humans were involved. The big difference between then and now is the Internet provides connectivity. Another difference is that then communications were one way. A project I worked on in 2003 collected data from GPS-enabled electricity meters. The sort of back-end we need depends in part on the nature of the devices that are connected to it. A building full of sensors for smoke detection, room occupancy, door locking, security cameras, lift, etc. might be managed by one local server in the basement. But a company providing that service to multiple clients with buildings logging and controlling everything from a dedicated data center would almost certainly require cloud storage. Many of the IoT use cases already exist, but the absence of technology is aided by faster communications with higher bandwidth. You can now buy a dashcam for your car that records the last 30 seconds or so before an accident. In a few years, I'll expect that your car will have multiple cameras recording the air around it 24/7 and streaming to an IoT backend. Watch out, car thieves. Managing car and truck fleets is cited as one of the important business-to-business use cases, tracking driving time, vehicle mileage, etc. Delivery companies use the data capture to help them improve their scheduled delivery windows and increase throughput. The problem is that the IoT means a lot of different things, so it's perhaps wise to look for generic solutions. In theory, you could use something as simple as a web server with a scripting language like PHP as a back-end. In reality, and especially with enterprise-type solutions, there's a lot more work needed. Services such as Script.io do much of the work for you. That's just one example I've picked. What work, you may be wondering? Here's a short list. Device management, user management and identity, messaging services, business logic on the server side, monitoring, reporting and backup services. And that's not even considering big data capture and the ecosystem around that for storing, manipulating, processing and publishing, data analysis and computation. You could develop this yourself using something more sophisticated than just PHP. Perhaps, for example, the free for non-commercial use Mako server, which lets you write web applications in Lua and optionally code in C and C++ that's called from the server. The Mako server runs on platforms as small as a Raspberry Pi. Mako is an application server similar to a web server, but better suited to running standalone programs as well as web pages. It's not that much different to JBoss, except it's written in C. If I were to place a bet on future IoT backend technology, my guess is that much of it will be powered by JavaScript and Node.js will be driving it. It's just 6 years since Node.js emerged as an alternative server technology to Java and .NET, and it lets you write JavaScript as a server-side language, which is quite amazing. Since then it's grown and grown and survived a major fork. The Node Package Manager NPM registry currently has over 206,000 packages listed. That's not bad. In proclaiming Node.js, I'm not excluding Java or C#. Java in particular has regained its #1 spot on the TIOB index this month, and like JavaScript it can run on anything and has better IDEs, but probably only because of its better maturity. C#'s limited by platform. Sure, you can run C# on Linux using Mono, but it's not that popular. So I see Java still being used in the enterprise space, where it's still very popular, but startups will be probably employing the cheaper JavaScript devs. But what about languages like Python, Ruby, Go or Rust? Could they be used for the IoT backend? Most certainly, but my intuition suggests it'll be JavaScript and Node.js that is the most popular. That's based on seeing the work currently happening. Thank you for watching this video. I'm David Bolton of Go Parallel.